Hey everyone, welcome back to the channel. UG Moldtech. In today's video, we are diving into the top 5 innovations in plastic engineering that are changing the way we think about plastics, their production, and their potential impact on the future. Whether it's sustainability, new materials, or mind-blowing manufacturing techniques, there's no denying that plastic engineering is evolving rapidly. So let's dive right in. Innovation number 1. 3D printing with plastics. We have the rise of 3D printing with plastics. This innovation is revolutionizing manufacturing and design. With 3D printing, engineers and designers can create complex plastic parts layer by layer, which reduces material waste and allows for a level of customization that was previously unthinkable. From medical devices to aerospace components, the ability to 3D print plastics in various forms is enabling more sustainable and cost-effective production. Plus, it's allowing for greater creativity and precision, opening up entirely new possibilities in the world of plastic engineering. Innovation number 2. Biodegradable plastics. Next on the list we have biodegradable plastics. These are a game changer for reducing plastic pollution. Traditional plastics can take hundreds of years to break down, but biodegradable plastics break down much faster and are more eco-friendly. Scientists are developing them from natural sources like cornstarch, sugarcane, and even algae, making them a promising solution to the growing waste problem. One example? PLA plastics derived from corn can be composted at industrial facilities and are already being used for packaging and disposable items. Innovation number 3. Flexible and stretchable electronics. Flexible and stretchable electronics are an exciting area of innovation, blending materials, science with electronics to create devices that can bend, stretch, and conform to different shapes without losing functionality. These types of electronics are used in a variety of fields, including wearable devices, health monitoring, and soft robotics. Stretchable conductive polymers. Materials like PDMs, polydimethylsiloxane, and EcoFlex are widely used as substrates for stretchable circuits. Graphene and carbon nanotubes, CNTs. Graphene is a single layer of carbon atoms arranged in a two-dimensional honeycomb lattice. Elastomers, stretchable polymers. Example, polypyrrole, PPY, or PDOT, poly, 3,4-ethylene-deoxythiophene. It's highly conductive, flexible, and stretchable. Innovation number 4. Carbon fiber reinforced plastic. Carbon fiber reinforced plastic is a composite material made by embedding carbon fibers into a plastic matrix. It's known for its exceptional strength-to-weight ratio, stiffness, and high performance. Key components of CFRP include carbon fibers, which are thin strands made from carbon atoms arranged in a crystalline structure. The plastic matrix is usually made from a polymer resin, such as epoxy, vinyl ester, or polyester. Innovation number 5. Self-healing plastics. Self-healing plastics are an exciting development in material science, designed to automatically repair damage or cracks without external intervention. There are several ways to create self-healing plastics, each based on different mechanisms: microencapsulation method, vascular network method, and supramolecular systems. In conclusion, the innovations in plastic engineering are helping us build a more sustainable, efficient, and technologically advanced world. From biodegradable solutions to self-healing materials and flexible electronics, the potential for plastic engineering is limitless. As these technologies continue to evolve, we can expect them to open new doors in industries ranging from healthcare to transportation, driving a more innovative and environmentally responsible future. The future of plastic engineering is bright, and with these cutting-edge innovations, we are not just imagining a better world, we are building it. And there you have it, the top 5 innovations in plastic engineering that are pushing the boundaries of what's possible. From bioplastics to smart materials, these advancements are not only improving performance, but also making the world more sustainable. If you enjoyed this video, don't forget to give it a thumbs up, subscribe to the channel, and hit that notification bell so you never miss out on more exciting content. Thanks for watching, and I'll see you in the next video. Bye.